Anita.
And I'm still Daniel.
Daniel, we've been talking about hybrid vehicles for a long time, but I do want to ask you, what is it all about in detail? I want to get to know it a little bit more.
I'm actually going to stop you right there just so you know, when you just say the phrase hybrid vehicle, actually you're referring to all vehicles that use two different propulsion systems.
Oh.
Yeah. So hybrid vehicle could also refer to like an electric bike or a train that uses two different energy sources.
Right.
So that's why the automotive industry uses the term HEV specifically to distinguish these from all the different kinds.
That's right. We learned about that last time, the HEV. All right, let's get to know it a little bit better.
Okay, as you already know, the HEV refers to a vehicle that's powered by the simultaneous or sequential operation of an internal combustion engine and an electric motor.
All right.
And you could say that because it wasn't easy to go directly from the internal combustion engine we've used for so long to the electric vehicles, that HEVs, they emerged as sort of an intermediate middle step.
Right, it's like an in-between. It's like a little half step before you go fully electric.
Yeah.
Just temporary.
Right.
So does that mean this is going to go obsolete?
Maybe, but we actually don't know how long this intermediate period is going to last. It could go for quite a long time. It depends on, the rate of technology. And because each HEVs offer some of the advantages of EVs and still allow users to fuel up with gasoline for long-range drives, that kind of convenience, it means that these HEVs are still pretty popular worldwide.
Well, then technicians here must know a lot about the HEVs.
They must. And HEVs are divided into three types. Two types of parallel hybrids and a power split hybrid. So, shall we take a look at them one by one?
Sure, why not?
All right.
In a power split HEV, the electric motor and the engine are combined in the gear set. The number 1 motor and the number 2 motor can rotate in the same direction, at different speeds, or in different directions, performing speed changes and acceleration. Because of this continuously variable transmission, power split HEVs have the strength of smooth speed changes. However, due to the structure's complexity, it is challenging when it comes to the maintenance. But more importantly, fuel economy may suffer due to the complex structural configuration. Next, there are parallel hybrids. The first method is the flywheel-mounted electric device, or FMED. In this configuration, the electric motor is positioned between the engine and the clutch. And due to this configuration, cars using this method always require a running engine. Therefore, the electric motor cannot propel the vehicle alone, limiting the improvement of the fuel economy of the vehicle. Another parallel hybrid is the transmission-mounted electric device, or TMED. This configuration is mostly used by Hyundai, which is more sophisticated and efficient compared to FMED. In this configuration, the clutch is positioned in between the engine and the electric motor, allowing the vehicle to propel only with an electric motor alone, to maximize the fuel economy.
Wow, that's a lot of information.
Yeah.
Okay, so in these TMED vehicles, cars can propel only with the battery and the motor, right? Well, in that case, shouldn't we just call it the battery electric vehicle?
No, actually, because the power of the motor, it's still not as strong as what you get in a battery electric vehicle, or BEV. Okay, this is a cross-section of the hybrid motor that we just talked about. In the Kona EV, it has a 150 kilowatt motor, whereas in the Sonata hybrid, it's only 38 kilowatts.
Oh, wow, that is a significant drop. I mean, is that still enough to power a car and move it forward?
Well, yeah, obviously, otherwise it wouldn't exist.
Oh, I guess so.
Okay, at low speeds, they run the motor, but above a certain speed, the motor only provides auxiliary power to the vehicle. Also, when you're driving high speed, if you release the gas pedal, then the engine turns off. Then, when you step on the pedal again to accelerate, then the engine restarts.
Yeah, I remember when these cars would first come up, people would say, isn't that bad for the engine? That's bad for the car, right? Turning it on, turning it off, back on and back off.
Maybe for internal combustion engine vehicles, but for HEVs, no, if that was a problem, wouldn't exist, right?
I guess so.
In fact, the HEVs, they use a different method to start the engine than you get in an internal combustion engine vehicle. Have you heard of the hybrid starter and generator? You may have heard it called HSG.
No.
The HSG is located at the front of the car, and that's attached to the engine. And it starts the engine, and it uses the power from the engine to charge the battery.
Okay, it's a big boy.
Shall we look at the Hyundai cars that use the TMED method?
Yes, why not? Are we taking a look at the Sonata HEV?
Yes. When Hyundai launched its first TMED hybrid model, it was the YF Sonata HEV. This is the Ioniq HEV. It's the first eco-friendly dedicated. And its official fuel economy, get this, 22.4 kilometers per liter.
Oh, wow, that is sweet.
Yeah, you're not the only person that's surprised. And then later on, hybrids were developed for the Elantra, Sonata, and Azera sedans. And now there are SUV hybrids for the Kona, the Tucson, and Santa Fe. Those have also been launched.
Yeah, I've seen them around, super quiet. I'm always impressed by them. So many hybrid models coming up.
Yeah.
It's unbelievable.
Yeah, and probably going to be even more.
So an HEV is a car with a motor and battery mounted on the internal combustion engine. Is that all?
Oh, no. Actually, the HEV system consists basically of an engine, motor, battery, inverter, and a few other proprietary parts. Let me show you. This is the battery, which is located under the second row seat.
Oh, okay.
Okay? And this is the electric motor.
Okay.
Electricity in the rear drives the motor, which is in the front.
Wow, okay, so this battery drives the motor when the car needs power. But I mean, I noticed a thing about HEVs is that there's no port for a plug to go in to charge. I mean, here's where the gas goes in, but there's no port.
Well, the car accelerates, then battery has to deliver electricity to the motor. Got it?
Okay.
Okay, so when the battery is almost empty, then it gets charged up using residual power coming from the engine.
Residual power from the engine.
Yeah, and then when the car decelerates, battery gets charged through regenerative braking.
I mean, but even still, can the battery be fully charged through those ways?
Yeah, well, it's because HEVs have a smaller battery than you get with PHEVs.
Okay.
Right? PHEVs have a battery capacity of 10 to 14 kilowatt hours, but HEVs have much smaller batteries that have a capacity of only 1 to 1.56 kilowatt hours. And that's why HEVs don't need separate charging.
Right, I guess so. Because it is relatively smaller, it can be charged with, as you said, the residual power from the engine and regenerative braking
There
as
you go.
well. Now, I've heard that the latest Hyundai models, they all have better fuel economies than other competitors. What's the secret there?
Well, it's because unlike other brands, the Hyundai hybrids, they have a clutch between the engine and the transmission. And then the motor gets attached to the transmission. It's actually really simple. By improving the HEV technology, that means the fuel economy gets increased gradually. And that's why Hyundai HEVs have a higher fuel economy at high speed than those of the competitors. So generally, for long distance driving, your fuel costs will rise. But in this case, it's much more advantageous.
Sounds great. You know, Dan, I'm going to make a bold statement here and say HEVs are close to internal combustion engine vehicles, okay? So I guess we can do maintenance on HEVs just like we do for the ICE vehicles. You know what I'm saying? They have an engine after all. They're both kind of similar. Come on now.
Okay, I know why you might think that, but that's not quite true. Because HEVs use a high voltage battery to drive the big motor. So before repairs, you got to take a lot of extra caution. It's just like what we were talking about with the EVs.
That's right. We need the PPE before we get to work.
That's right. Now, here's the steps. Step number 1, first thing you got to do is put up a sign that states that a high voltage vehicle is being repaired.
Beware.
Right. People around don't stumble across it and Then you need to set up a protection barrier, like something like that right over there around it in order to control access.
Sure.
Next, you need to wear, as you said, personal protective equipment. That's right here. And that will prevent the high voltage from entering the fragile human body.
Sure, we got the face shield, the gloves. What is
And
this?
This is the insulated equipment. No straight metal, it's
Okay.
insulated.
So with all of this, we can finally do some maintenance work on EVs safely.
Up. Hold on. We haven't yet talked about the most important thing, okay? You have to be sure to pull out the service interlock or service plug for the high voltage current. Gotta remove that.
All right.
Okay? Only after you've completed all those steps, sign, barrier, protective equipment, pull out the service interlock or service plug, then you can start the maintenance.
There you go. Check all the safety gear before, because safety is the most important thing.
Exactly. So, in the next session, we'll look in detail why exactly high voltage is so dangerous and also how to use all of the fine protective equipment.
Can't wait.